Hey, what's going on, guys? Against here. In this video we'll learn how to work with counters and masks using Python and OpenCV. So we'll take 3 essential steps to separate the object from the background and put it onto the new one. So the first step is to find the counters of a current given image. Then we need the second step is to find the most significant counters to mask the background, and finally we need to separate the object and merge it onto a new background. This is pretty it. So if you're interested, without further ado, let's actually start writing some code. Okay, so first we need to import a couple of packages. I want to say import CV2 and import numpy as np. Then I want to open source image file, and I can simply say image equals to cv2.imageRead, and the file name is face.jpg. So I have the image in the current working directory. Here is the image that we're supposed to be working with, so I hope it's clear. And I want to leave it unchanged, so let's say cv2.imageRead and unchanged. So then we would be working with this, would be converting this to grayscale and to black and white, even though it's already kind of like black and white still. It's kind of RGB. I'll show you this just right in the moment. But before that, let's actually display the image in a window, and we can simply say cv2.imageShow. So let's call the window like image. Let's say image original. Let's just say original image. Okay, and the image itself, then I want to provide the escape condition. So cv2.wait key, and wait for whatever key being pressed, and let's say clean up. Finally, we want to clean up the windows. So cv2.destroy all windows. So this last 3 lines are just needed for debugging purposes. So nothing special here really. Okay, just let me specify the folder properly. Okay, so I need to open the terminal in the current working directory, and by typing Python 3 counters.py. I hope to see the image. Okay, perfect. So here is the deal, guys. Here is what I wanted to show you. So if I just say print image, and let's say like this, we'll see that we have red, green, and blue value. So it's not even it's not black or white, so it's kind of like very light sort of a spot here. I'm not sure which pixel in particular which pixel in particular that does these values refer to in particular, but just to give you an idea, it's not a black, it's just RGB, it's not black and white. So we need to convert this image to the actual black and white image. So now let's actually do this. So first we'll convert the image to the grayscale. So I want to convert image to grayscale, and let's say image gray would be equal to cv2 dot, I'm using cvd color, which stands for convert color, and then the original image, the original image as the first argument, and cv2 color bgr to gray as the second one. So now we have a look. Doesn't change that much, but it's already different. Okay, so we now just print if we now print the image gray, parameters. Well, we only have one, so it's the grayscale currently, but now we need to use the threshold to convert image to black and white. So let's call it image edges. Image edges equals to cv2.threshold. So I'm using this image gray as the initial source, then the threshold, let's take it 100, then the maximal value would be white, and the threshold itself would be cv2 thresh binary, like this. And yeah, I just need to specify another value. We're not going to be using this, but still. Okay, and now let's print the image edges, sorry, and bring the value as well. Okay, so now we have white, or otherwise it would be black, which is good, and now we have the pure black and white image. So now it looks like a little bit different, so I hope it's clear. Okay, so from now on we can actually start working with our counters, and the function that I'm supposed to be using for this sort of a purpose is called find counters. So, but before that, we need to create a couple more of, well, let's say canvases, right? The first one would be used to showcase how the counter is being retrieved, like the order, the counter traversal order, to show this like visually, because that's the most didactic, the most easy way to figure out the difference between the retrieval of the counters. And also another canvas would be for mask. Another canvas would be used to mask the background. So first, let's actually define. Let's define canvas. Define canvas. Let's say create canvas. Create canvas, and another one would be create background mask. So here we make use, and we should make use of the original image. So let's call it canvas. Yeah, canvas would be equal to np.zeros, and I'm using image shape just to cut literally to make the exactly the same shape as the image has. It's the width, height, and the number of like RGB. I'm gonna forget the word. The number of channels. I'm sorry, and also the size for like uint8 or whatever. So the size of every single element within the array would be also the same. So we can simply use this image shape. Well, no, actually, sorry, I need to specify this the size manually. Okay, and we can now have a look at our canvas. So currently it should be black, kind of like one. Okay, and we also need to make it white. So let's say canvas.fill and with white pixels all along the way. Okay, good. And the next thing, I want to do the same but for mask. So this would be mask. And actually we can also fill the mask. Well, there are different ways of how to deal with masks, but I prefer to have the white mask initially. Maybe not the best ever practice, but still that's the way I'm doing this currently. Okay, now so the mask is also just a pure white screen at the moment. Okay, so the next thing to consider, now we can actually start extracting our counters. So let's say we would be using the different retrieve modes for counters. So let's say get counters, let's say get all counters, and here we'll use get most significant counters. I really hope that I didn't make any spelling errors. If I didn't, please forgive me that, guys. Okay, so here, okay, let's actually create two variables first. So counters, and this would be counters, let's call it counters draw, and then hierarchy. This one is just it just needed here. We're not going to be using this hierarchy here, but just needed because of exactly two return values of the function that we're supposed to be using. So we're using function cv2.find counters, and it takes several parameters. So first of all, we need the image that we're supposed to be using as a source, and in our case this is called image edges. Okay, and then the way then we need to specify how actually we want to retrieve our counters. So retrieve, let's start with a list. Okay, and another parameter that we're not supposed to be covering in this tutorial at very least is called chain approximation. I'll use chain approximation none. So it's not important for us in this particular case. Okay, so we already have our colors, which is good. And okay, so probably we're not going to be touching this. Well, actually, hold on a sec. We can get the most significant this way. So let's call it colors mask. And instead of retrieving list, we just retrieve external like this. So I want to show you guys how to the traversal order of a list of given counters. But before this, let's actually go for drawing all the counters at once. Okay. So let's say draw counters. This would be draw all counters. I'll comment this out later on, but for now I can say cv2.draw counters, and it takes a bunch of parameters as well. So first, where do we want to draw these counters on or at? So the canvas. So I want to draw these counters on the canvas on this kind of element. So eventually we want to show the canvas. Then we need the counters that we want to draw, that we want to use. So I'll use this counters draw here. Then if I specify index -1, it would draw all the counters at once. Then I need to specify the color for which color to use for counters. This would be black, this would be green, for instance. And eventually we need to define the thickness. So let's take it equals to 3. And if I did everything properly, we should now see the counters being printed, being kind of painted. Okay, this green stuff annoys me, so I prefer working with black counters. So let's go for it. Okay, now we have the counters. So the next thing to consider is the traversal order of the counters, and let me try to explain what I mean by saying this. So we can say we can use the certain index to specify every counter in separate. So let's write a simple for loop to loop over all the counters. So here we want, so just comment this out. So I want to draw counters. Well, let's better call it counters traversal. Okay. So for counter in counters draw like this, I just want to. So here we'll say draw current counter, okay, and like this. And also I want to, just for debugging purposes, so I want to wait for key and and I want to show, I want to update the image as well. So you will now see what I mean. So sorry. Okay, let's better do slightly bit different way. So let's say range, length, counters draw, and here counters draw, counter like this. Okay. Sorry guys, yeah, we need to use just the bare index here. I'm sorry, we need just to use the bare index. And yeah, so now you see the counters are being displayed one by one in some sort of a specific order, and this is the order that we have in case of retrieving a bare list of counters. So just listing all the counters. Now if we change this list to tree, in this case we start from the most significant counters and then we go to less significant counters. And this reminds me doodling animation at some point, which I was trying to mimic recently. So yeah, this is how it works. And okay, hope it's clear. But anyway, in this tutorial we're not going to be playing around with this sort of a thing in particular. So I would be sticking to the list here. And the next thing to consider, we need to okay, also I want to show how this what does this retrieve external means. So let's probably just copy this part, and here let's say most significant counters traversal. So I don't want to print here anything any longer. So here we're using the counters mask, just retrieves the only external or the most significant ones. And let's have a look what kind of counters we got here. Okay, something is gonna be wrong. Yeah, sorry guys, just draw this to the canvas. I want to draw it on a mask instead and use the mask here, because here we're already gonna draw everything we had on a canvas. So yeah, we just need to specify the mask instead. And yeah, let's also display the mask. So make sure that we drawing on the mask. Okay. And this is pretty it. So you see, like, we don't have that many counters any longer. Okay, so these are all the counters we actually have. So now the next step to consider, we need to fill this counter and this counter and this counter with kind of black pixels, right? So to formulate a sort of a mask. So in order to achieve this kind of goal, we're going to be using the method that is called fill convex poly. So we can simply change this one to fill convex poly. So filling the polygons literally. Here we need to actually specify, we need like the points formulating many polygons. So we need this points. Okay, and here is the color, and we don't need thickness, so it's just much easier to show rather than explain. So here we go. And now the only problem is that I don't really want this central one to be masked. So I just need to disable the certain index. So index 0, index 1, 2, 3. So I just want to disable index 1 now. So we can simply say if counter is not equal to 1. Sorry. Okay. And now, yeah, we just skip that. Okay, now we have this mask. Okay, awesome. So no more need for this kind of debugging stuff here. And we can show, so let's show the original image, and let's start. So let's say, let's use this one, the original image. Let's show contours and canvas here, canvas, and also let's use the background mask, and sorry, background mask and the mask. Okay, yeah, and we didn't yet put image onto a new background, but for now let's just stick to this kind of guys. So yeah, here is the order. So we have the original image, then we have this then we have this kind of edges, this contour is being extracted, then we have the background mask, and now we need to use probably we can actually create a new background. We could have actually used the mask for this purpose, but just for clarity and didactic purposes, I'll create one more kind of new background. So I think, yeah, that would be just easier to understand. So here, let's say create new background. Okay, so this might be whatever. I would be using just the green screen there. It might be whatever image, doesn't matter really. So let's call this new background, and okay. And now apparently here, so let's say create mask, and here I just want to create background. So I want to be using this new background. I could have used the mask, but again, just for clarity purposes, just to make it more didactic, and make it green. And let's show the image with a new background. So it's just like the mask, but colored to green. Okay, so here is the background. Yeah, let's actually call it. Okay, just need to give a new name to a window. So this would be new background. Yeah. So we have the new background, we have the background mask. So again, instead of this green sort of a thing, there could be whatever image, just to give you an idea. And here we have the original, so contours, background mask, and the new background. Okay, so the very last thing to consider is just to put this original image to this new background. That's pretty it, so let's go for it. So let's probably create one last window. So let's call it CV2 image show. Let's call it output. Okay, and here I use CV2, my favorite bitwise and we're using the new background, and we want to bitwise and this. No, not so fast. Hold on a sec. So first, let's first make it with the mask. So let's take the mask and the image. Okay. Yeah, and okay. Or yeah, we can actually use this new background just directly. Yeah, so yeah, I think we can do just like this. So yeah, awesome. So the eventual output, the new background. Okay, too many windows already. We have the mask, we have our contours, and we have the original image. So yeah, let's quickly walk through the process step by step. Again, like so, we can start with the initial image, then we do extract the contours, then we extract the most significant contours to mask the background, then we create a new background based on that sort of a mask. Okay, so green color just represents whatever background we have, and eventually we want to put our original image onto this new background. Well, okay, so I try to make this tutorial as simple, as didactic, as clear as possible. So thanks for watching, hope you liked this. So this is it from my side. Until the next time, and take care.